Hello everyone. I wanted to talk about this new project I have been working on, which utilizes Unity's ML Agents package to train an AI to dodge bullets like Neo. The eventual goal of this project will be to create a two-player shooter game where the human player will compete against an AI player to dodge each other's bullet and try to shoot the other guy. In this video, I will discuss how I completed phase 1 of this project and train a reinforcement learning agent to jump over randomly generated bullets. The next phase will consist of introducing more abilities like a dash or a duck, extending this to a two-player setting, and add more pizzazz into the game with some music, sound effects, animations, and make it more fun to play. So, I have been working as a researcher in the field of reinforcement learning and in the industry as a machine learning scientist for about 3 years now. In fact, my graduate thesis was about making arbitrary physics based 3D characters learn to dance to music using reinforcement learning. What keeps the planet spinning? Ever since I picked up a passion for game development in Unity a couple of months back, I've been wanting to marry my two areas of interest into a game. And this project is not my dream game, but it is a gateway to that. Without further ado, let's get this devlog on the way. The very first thing I did was create a new Unity project, install the ML Agents package from the package manager, and set up the scene with a basic ground and a 2D box for a character. I used a character controller from a previous project to add some basic controls for the game, like moving and jumping. The jump is also enhanced, so holding the jump button longer will make the character jump higher, and releasing it early will do a shorter jump. Next, I created a bullet prefab that initializes in the scene and moves from right to left with a configurable velocity. I added a trigger so the player resets when the bullet hits it, and to identify if the player successfully evades a bullet, I added another large box collider to the player slightly behind the body and then set it as a trigger. Next, I created a game object that spawns these bullets after random intervals of time. Instead of destroying and instantiating my bullet game objects a bunch of times, I used object pooling to instantiate 5 bullets at the start of the scene and schedule how long they are going to be active and where they originate from. I don't know about you, but man, it always feels awesome doing object pooling. Next, I duplicated the spawner to have two of them in the scene. The one positioned higher will fire the bullets with a slower speed than the lower one. And then I did some playtesting to check all of it is working, and it seemed pretty ready to go to the next step of training. If you're unfamiliar with reinforcement learning, here's a 30 seconds primer. Reinforcement learning consists of an agent and an environment. The agent interacts with the environment by taking actions, and the environment gives it rewards depending on how well it's doing. This reward is positive if the agent does something good, like jumping over a bullet, or it can be negative if it does something bad, like getting hit by a bullet. The goal of deep reinforcement learning is to collect these experiences and then train a brain or a deep neural network to take the right actions at each state in order to maximize the cumulative rewards during the agent's lifetime. So first, I tackle writing the code for the action space in this onActionReceived function. This tells the agent what actions it can take in the environment. Now this was very simple to accomplish as I had already set up the player controller beforehand. I set the action space as discrete with two action types. The first one is for movement, which has three branch types: to move left, right, or stay still. The second action slot is for jumping, which has two branches: jump or not jump. Second, I handled the reward structure. I kept it simple and I added a reward of +1 whenever the agent dodges a bullet and a reward of +0.1 for each step that the agent is alive. The additional reward of point 1 helps the agent to receive a more denser signal and helps to train the agent faster. I also added a penalty of -1 when the agent gets hit, and that also terminates the episode. Third, here's what I did for the observation space. I include the agent's current local position and velocity. Then I did a box cast to find the distance and direction to the 3 nearest bullets in front of the agent. I took the normalized distance value stored in the fraction component of the ray cast hit to the object. For the direction, I also converted it into unit vector through the normalized vector2 function. If less than 3 bullets are present in the scene, I padded those slots with 1 and 1, 0. Finally, for faster learning, I recorded some of my own gameplay as demonstrations, and I will be pre-training on these demonstrations using behavioral cloning before the RL loop. ML Agents also makes this quite trivial to do, so there's almost no reason to always do some demonstrations in my opinion, unless you're doing this for research or benchmarking a gym environment. One very important lesson I learned along the way was that when using coroutines and schedules with ML agents, it is very, very, very important to use scaled time instead of unscaled time. In other words, suppose you want your bullet spawner to spawn bullets every 2 seconds. You use wait for seconds instead of wait for seconds real time. This is because training with ML agents will run the physics updates much faster than when you're playing in the editor. Generally, the time scale is about, say, 20 times faster by default. So, if you use unscaled time, then entire episodes might finish before any bullet gets fired. And so the agent isn't going to see any bullets and it's not going to learn anything. Before diving into the results, I will request all of you watching to please subscribe, leave a like and comment on this video. I am starting out my YouTube journey, so I truly value all the feedback and interaction that I get on my work. If you subscribe, you are going to make my day. Then I exported a build of the game and began training parallelly on 4 environments in the no graphics, no rendering mode. The results look pretty interesting. In the first few steps, the agent struggles to do much. It just runs away to the left to stay alive as much as possible. Smart. After some more steps, I can see that the agent has begun learning to move and evade bullets by jumping, but it still lacks discipline. It gradually keeps improving as the time passes on. After about 1 million steps, the agent has gotten pretty awesome at dodging those bullets. And this guy has beaten out my own high score by quite a margin. And then training more and more just makes the agent even better with even human level performance, in my opinion. Then I pretty much sat back and enjoyed this little thing jump over bullets for an eternity. I kind of like how it makes space for itself while jumping, and the way it uses the long jump and the short jump according to the situation by looking at the next bullet coming after the closest one. Overall, I had a lot of fun working on this version. For my next video on this series, I'm going to introduce a ducking mechanic and maybe a dash mechanic as well to get out of tight situations. And then I'm going to scale this and make it into a 2-player game with 1 player controlled by a human and the other will be a trained reinforcement learning AI agent. I'm very excited for all of that, so if you want to be notified, please subscribe to my channel. I'll see you next time, cause you are magnificent!